Welcome to Statics Lectures by Civil Thinking, and today we are going to solve another problem on force systems, that is movement due to force and couples. Now before I move on, I suggest you to please watch the video lectures step by step in sequence as in the playlist so that you understand better. The playlist link is in the description or you can also click here. Now coming to the problem, a 100 centimeter meter rule is pivoted at its midpoint. If a weight of 2 Newton is hung from the 20 centimeter point, calculate the amount of force required to be applied at the 80 centimeter mark to keep it in a balanced position. Now, we are provided with a scale, a meter rule. We also call this thing as scale, okay? Now, it's called as meter rule. Now, let us say this is 0 centimeter mark and this is 100 centimeter mark, right? Because in a meter rule you have like this. Now let me say this is the midpoint. The midpoint have to be 50 centimeter mark, right? Now a weight of 2 Newton is hung from the 20 centimeter, right? Now let me say this is 0, this is 10 and this is 20. Let me say this is 20 centimeter mark. Now we have applied a weight of 2 Newton from here, right? 2 Newton. Now calculate the amount of force required to be applied at the 80 centimeter mark. Okay, now where will be the 80 centimeter mark? Now let me assume the 80 centimeter mark is somewhere here. This is 80 centimeter mark. Okay, now we have to calculate the force to be applied at this point. I forgot to say that this scale is pivoted at the midpoint, means at 50 centimeter mark position we have placed something like this, right? And we have to calculate the force F so that this meter rule is balanced on at the point B C, okay, on the point C. Okay, now this meter rule will be in balanced position at point C if it is in static equilibrium at point C, right? And it will be only in static equilibrium at point C if the summation of moment at point C is equal to 0. Okay, now if you don't know about static equilibrium, please watch my video lecture on static equilibrium. When the summation of moment at C is 0, it will be in static equilibrium, right? Or it will be balanced, right? It will be in balanced position, right? Now so let us find summation of moment, the net moment at point C, and we will see whether it is 0 or not. If it is 0, so it will be balanced. Now again I'm assuming the anti-clockwise moments at point C to be negative and clockwise movement at point C to be positive. Now 2 Newton, it will exert an anti-clockwise movement like this, right, at point C. So I'll write negative 2 Newton multiplied by, now how much is 2 Newton far from point C? Now it is 50 centimeter mark, it is 20 centimeter mark. So the distance between 20 centimeter mark and 50 centimeter mark is 50 minus 20, which is 13, right? Now there is a force F, because we assumed that the force be F and it is downwards. We have assumed that we need F force downwards to be applied at 80 centimeter mark, then it will be balanced. Then we will find the value of F, that will say us everything. Now F will exert a clockwise movement like this, so it is positive, plus F multiplied by, how much is F force far from 50? Now it is 80 centimeter mark and this is 50, so the distance between them is 80 minus 50, which is 13. Okay, we will assume it to be 0. Why? Because that will give us the balanced position. Okay, now when we say this is 0, it means it will be balanced. because that is what we had to find. We had to find the force required. We had to find the value of F such that the meter rule is balanced. So we have made it balanced and we will find the value of F. Now 30 and 30 will cancel out. So we are left with minus 2 plus F is equal to 0. When we simplify this, we will get F equal to 2, and this is Newton, right? So we get a positive value of F, 2 Newton. It means if it was minus 2, that would have meant that the F is not downwards, it is upwards. When we get a positive value of F, it means our assumed downward direction is correct. Okay, so what we need a force of 2 Newton, right? 2 Newton to be applied at 80 centimeter mark, and that also downwards. Then the meter rule will be in balanced position. So which is the correct option? Option B, 2 Newton downwards, right? This is how we solve this problem. If you have any doubts, please comment, and see you in the next class. Thank you.